Hello and welcome to my channel. So in this video we will be dealing with the problems under exercise 1.4, which is related to types of functions. So the first question here under this exercise is determine whether the given graphs below represent functions and also give reasons. Okay, so you have 4 different graphs which is already given in the textbook, and you're going to find out whether they are functions or not using vertical line test. You are not using horizontal line test because horizontal line test is used to check whether the given function is one-to-one or not. But here the question is only to check whether it is a function. So here, therefore we will use the vertical line test. Okay, you can draw the vertical line at any part of the curve. So I am drawing here. If I draw, we find that the line is intersecting the curve at 2 points, and you know that it should intersect only at 1 point, only then it is a function. Therefore first one is not a function. Now second sum, again I am drawing a vertical line here, or you can draw it here. Here we find the intersection is at only 1 point. Again the intersection is at only 1 point, which shows that it is a function. Now for third subdivision, I am drawing the line here. You can also draw this side. So if we draw, I find that the curve is intersecting the line at 3 different points, which shows that it is not a function. Now for the last subdivision, suppose I draw the vertical line here, or you can also draw this side. So we find that the curve is intersecting the line exactly at 1 point. Therefore we will conclude the reasons as subdivision 1 and 4 are functions because the curve touches the line at 1 point. Subdivisions 2 and 3 are not functions because they touch the curve at more than 1 point. Therefore this is how we do the first problem. The second question, f is a function from a to b and it is defined by f of x is equal to x by 2 minus 1. Set A and set B is already given to you. You have to represent this function by ordered pairs, table, arrow diagram and also graph. So first we will substitute values of A in place of x and we'll find out the corresponding y values. Okay. So if suppose x is equal to 2, the first value here, what will happen? F of 2 is equal to 2 by 2 minus 1, 1 minus 1 equal to 0. Then x is equal to 4, f of 4 is equal to 4 by 2 minus 1, so 2 minus 1 you will have 1. When x is equal to 6, f of 6 is equal to 6 by 2 minus 1, so you will have 3 minus 1 as 2. When x is equal to 10, f of 10 is equal to 10 by 2 minus 1, when you cancel you get 5, so 5 minus 1 you get 4. When finally x is equal to 12, f of 12 is equal to 12 by 2 minus 1, so you will have 6 minus 1, which is equal to 5. Now from this we can write the set of ordered pairs. So the first set will be 2, 0. Next set will be 4, 1. Then 6, 2. Then 10, 4 and 12, 5. So this is how you write your ordered pairs. Next is a table. Write all your x values here, which is from the set A. So you will have 2, 4, 6, 10 and 12. Now your y values will be the corresponding images. So you will have 0, 1, 2, 4 and 5. Now for the arrow diagram, domain and the codomain. Domain is from the first set, so 2, 4, 6, 10 and 12. Codomain is from the second set, so you will have 0, 1, 2, 4, 5 and 9. Now map them by looking into the table. So you will have 2, 0, 4, 1, 6, 2, 10, 4 and 12, 5. So this is how you do your arrow diagram. For graph, roughly take your x-axis and y-axis. Here x-axis I am taking 2 units and y-axis I have taken 1 unit. Just map them by looking into the table. So first is 2, 0, where we will mark on 2, 4, 1, 6, 2. Then you have 10, 4. Then you have 12, 5. After drawing, after plotting, join them with a straight line. So this is how you do the ordered pairs, table, arrow diagram and the graph. The third question, represent the function f which is already given to you through arrow diagram, table and the graph. Here you need not substitute your x value, y value and find out the ordered pair. Instead, the ordered pair is already given to you. So we will draw the arrow diagram now. Take it as A and B. Now A contains the domain elements, right? So domain elements means the first set of elements. So 1, 2, 3, 4 and 5. So I'll write 1, 2, 3, 4 and 5. B is the codomain, which is the second set. So you'll have to pick out the second elements. Repeated elements you can write only once. Okay. So here we find 2 is repeated thrice, and 1, 3 and 1, 4, right? So we'll write 2, 3 and 4. Now you can map them 1, 2, 2, 2, 3, 2, 4, 3 and 5, 4. So this is how you do the arrow diagram. Now for the table, write your x value and your y value. What is your x value? The first set, right? So 1, 2, 3, 4 and 5 you will have. Your y will be the codomain 2, 2, 2, 3 and 4. Now the graph. So you have 1, 2, I'll plot it here. 1, 2, then 2, 2, then again 3, 2, 4, 3 and 5, 4. Just join them. So this is how you do the graph. Now the fourth question, show that the function from n to n defined by f of x is equal to 2x minus 1 is 1 to 1 but not onto. So the function is from natural numbers to natural number. The function is already given to you. You have to check whether it is 1 to 1 but not onto. Okay. So first we will substitute values in the place of x and get the corresponding values. It is natural number, so I'll start with 1. So f of 1 will be 2 into 1 minus 1. Now it goes on like this because it is natural numbers. There is not going to be any end. Okay. Now to check whether it is 1 to 1, we'll have to draw the domain and the codomain. I'll take this set. It is from the natural numbers to the natural numbers, or you can also write it as A and B. Okay. So natural numbers 1, 2, 3, 4, 5 and it goes on. Similarly here 1, 2, 3, 4, 5, 6 and it goes on. Okay. Now map the elements 1 with 1, 2 with 3, 3 with 5 and it goes on like this. So every element in the domain is having a unique image in the codomain. Therefore the function f is 1 to 1. The reason is because every element in the domain has an unique image in the codomain. Now to check whether the function is onto, you know by definition the range should be equal to the codomain, only then the function is said to be onto. Here it clearly shows that the range is not equal to codomain because there are few left out elements like 2, 4, 6 and it will definitely continue, right? So there is elements which are not mapped, which do not have a pre-image. Therefore f is not onto because range is not equal to codomain. So with this we complete the fourth problem.